Hi, welcome to my channel. In this video, we want to solve the following problem. Given triangle ABC with angle B equals 4 theta and angle C equals theta, draw AD perpendicular to BC. Given that AB equals 3 units, BD equals A units, and CD equals 10 units, find the length of A, where A is less than 10. And now for the solution. First, let the length of AC be y. Next, from B, draw a line cutting AC at E and such that angle EBC equals theta and angle ABE equals 3 theta. And then, consider triangle EBC and the line AE. Since angle EBC equals angle BCE equals theta, triangle EBC is an isosceles triangle. Therefore, we have BE equals CE. Let's denote the length of the two line segments as M. Then the length of AE equals y minus M. Next, draw EF perpendicular to BC. Thus, EF bisects BC. The length of CF is therefore given by 10 plus A over 2, while the length of DF equals 10 minus 10 plus A over 2, or 10 minus A over 2. Following this, consider triangle ADC and the line EF. Let's apply the intersect theorem to triangle ADC. Given three parallel lines, L1, L2, and L3, that intersect two straight lines at ABC and XYZ respectively, the intersect theorem tells us that AB over BC equals XY over YZ. Applying the intersect theorem to triangle ADC, we obtain AE over CE equals DF over CF. Substituting the values of the lengths, we obtain y minus m over m equals 10 minus a over 2 divided by 10 plus a over 2, or y over m minus 1 equals 10 minus a over 10 plus a. After adding 1 to both sides and then cross multiplying, we obtain m equals 10 plus a over 20 times y. Next, consider angle BEA, which is an exterior angle of triangle EBC. Since an exterior angle equals the sum of interior opposite angles, angle BEA equals theta plus theta, or 2 theta. Following this, consider triangle ABE. From B, draw a line cutting AE at G, and such that angle GBE equals 2 theta and angle ABG equals theta. Since angle GBE equals angle BEG equals 2 theta, triangle GBE is an isosceles triangle. Therefore, we have BG equals EG. Let's denote the length of the two line segments as N. Then the length of AG equals y minus m minus n, while angle BGA, which is an exterior angle of triangle GBE, equals 2 theta plus 2 theta, or 4 theta. Next, consider triangle ABG and triangle ACB. Let us show that these triangles are similar. Since angle ABG equals angle ACB equals theta, and angle BGA equals angle CBA equals 4 theta, by the AA similarity theorem, the two triangles are similar. Since corresponding sides in similar triangles are proportional, we have AG over AB equals AB over AC equals BG over BC, or y minus m minus n over 3 equals 3 over y equals n over 10 plus a. From y minus m minus n over 3 equals 3 over y, we have y minus m minus n equals 9 over y. From 3 over y equals n over 10 plus a, we have n equals 3 times 10 plus a over y. Since y minus n plus n equals y, we have 9 over y plus 10 plus a over 20 times y plus 3 times 10 plus a over y equals y. Multiplying both sides by y to clear the denominator, and after rearranging, we obtain 10 minus a over 20 times y squared minus 3 times a plus 10 minus 9 equals 0. Going back to our diagram, let's apply Pythagoras theorem to triangle ABD to obtain AD squared plus A squared equals 3 squared, or AD squared equals 9 minus A squared. Applying Pythagoras theorem to triangle ACD, we obtain AD squared plus 10 squared equals y squared, or AD squared equals y squared minus 10 squared. Equating the two expressions for AD squared, we have y squared minus 10 squared equals 9 minus A squared. After moving 10 squared to the right hand side, we obtain y squared equals 9 plus 10 plus A times 10 minus A. Substituting the expression for y squared into the previous equation, we have 10 minus a over 20 times 9 plus 10 plus a times 10 minus a minus 3 times a plus 10 minus 9 equals 0. If we simplify to the equation, 10 plus a times 10 minus a whole square over 20 minus 3 times a plus 10 minus 9 times 10 plus a over 20 equals 0. 10 plus a cancels out, and after multiplying both sides by 20, we obtain 10 minus a whole square minus 60 minus 9 equals 0, or 10 minus a whole square equals 69. Since a is less than 10, taking the square root gives us 10 minus a equals square root 69. Therefore, a equals 10 minus square root 69, which is the solution to our problem. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.